I wanted to do medicine. I was brought up in a medical family, really sort of imbued in medicine from a young age, across the dinner table, talking about, medical cases, medical problems. I get this call in 1991, my, second year of medical school. My father calls me to say that he's got numbness between his legs and he's got a cancer in the bottom of his spine. And he had high-dose chemotherapy and radiation to the spine, and for a high-grade B-cell lymphoma. And he, 25 years later, he was still working in the National Health Service. And I think that illustrated to me how, intense research in cancer biology and cancer medicine, where you have discovery scientists working with cancer clinical trialists and clinicians, can come together and make a massive change over 2 or 3 decades. And I wanted to be part of that. So this is the Francis Crick Institute. It's a biomedical research centre, roughly 1,500 people, 120 labs. I liken it to a cathedral of science. And so now I sort of split my time between the lab, mainly, and the clinic. The questions from the clinic inform the laboratory programme from beginning to end. Everything we do in this lab is aimed ultimately with a line of sight to the clinic. We study how cancers evolve and adapt over space and time. That is, how do cancers become resistant to treatment? Why do cancers spread? How do they spread? How do they evade the immune system? The study is called TracerX, which stands for Tracking Cancer Evolution Through Therapy, RX as in therapy. So what we're aiming to do here is we take patients with very early stage lung cancers and we follow them up from diagnosis through to either cure or recurrence and death. And by understanding how we cure patients and separating them from those that we don't cure and relapse and die, we hope we can start to understand some of the fundamental rule books of cancer evolution that will predict poor outcome, that we can ultimately intervene and perhaps block those evolutionary paths so one day those tumours can't progress and the patients can live. So Achilles Therapeutics was a company we set up about 5 years ago to take the findings from the lab, where we found that truncal mutations, these are mutations present in every tumour cell, some of these could be recognised by the immune system. And what's happening over cancer evolution is that the immune cells are being suppressed from recognising those truncal mutations. And so we found ways of priming the immune system against these mutations to maximise the benefit that the immune system can bring to bear against the tumour. Cancer at the cellular level is extremely rare, and so there are many, many tumour suppressive mechanisms in our bodies that prevent cancer from developing. And that's what's so fascinating. If we understood those processes and we understood why cancer at the cellular level is so rare, I think we could engineer new ways of preventing cancer. And that's what we're trying to do over the next 10 years now, is moving towards a sort of phase of what we call molecular cancer prevention, whereby understanding the rule books of how a cancer starts in the first place, we can intervene to stop it happening right before it starts.